This video is going to be a quick introduction into solubility product constants, or sometimes we call these KSPs, and then it'll be followed up with several example videos. So a solubility product constant is just an equilibrium constant, but it's an equilibrium constant for a specific type of reaction. The type of reaction that we're imagining is that we have excess solid along with a solution that's saturated in that solid. And so what's happening is new solid continues to dissolve, but because the solution is saturated at the same rate, solid that was already dissolved is reprecipitating. We usually talk about solubility product constants, or KSPs, for ionic compounds that have low solubilities. So the general equation we're imagining is we have a solid reactant, and then that's in equilibrium with its dissolved ions. And so in general, the expression for the solubility product, it's just an equilibrium constant. So it's the concentrations of the products raised to their stoichiometric coefficients divided by the concentration of the reactants. But since the reactant is a solid, it won't appear in our equilibrium constant expression. All right, so this slide is really just a note on terminology. So I want to distinguish between the terms solubility and solubility product. So the solubility is a term that we've encountered before. This is just the maximum amount of solute that can be dissolved in a given amount of solvent, right? So this is how much of that solute will dissolve. And we usually express that as molarity or moles per liter. The solubility product is the equilibrium constant expression for the reaction of a dissolution of an ionic compound, right? So we'll do a quick example here. So we want to write the solubility product expression for lead 2-phosphate. So in order to do that, the first thing I need to know is what is the formula for lead 2-phosphate? So this is an ionic compound, so it's all about the charges. And lead is one of the metals that can have many possible charges or oxidation states. And so when they give the name of this compound, the Roman numeral 2 here tells me that the lead is positive 2. So I have lead with a positive 2 charge. I have phosphate, and so we know that phosphate is PO4 3-. So then, in order for the ionic compound to have a 0 total charge, the charges of the metal and the polyatomic ion have to cancel. And so that will happen if I have 3 leads. So 3 times 2 plus will be positive 6. If I pair that with 2 phosphates, 2 times negative 3 is minus 6, then the charges will cancel. So the formula for lead 2-phosphate is I need 3 leads for every 2 phosphates. So then the chemical reaction for the dissolution of lead 2-phosphate is going to be, if I have solid lead 2-phosphate, then that's going to dissociate into 3 lead ions and 2 phosphate ions. All right, and so that's the chemical reaction for the solubility product. So then to write the equilibrium expression, or the KSP expression, which is the solubility product expression, it's going to be the equilibrium constant is going to be the concentration of lead 2 cubed times the concentration of phosphate ions to the second power. And so this is the KSP expression for lead 2-phosphate. So in order to write that, I had to first figure out what is the formula of the ionic compound, then write the chemical equation for its dissolution, and then the solubility product expression is just the equilibrium constant for this reaction. All right, I mentioned this on the second slide, but it's worth emphasizing. We typically use KSPs for ionic compounds that have low solubilities, or even for compounds that we might have classified as being insoluble in Chem 1. So the reality is, even when we say something is insoluble, a small amount of it will in fact dissolve. And so the KSPs are the equilibrium constants that we use for describing the chemical reactions that describe that dissolution. So I'm not going to go through the solubility rules. This is just here to remind you that these exist and that you might want to go back and refresh your memory on these and how to use them. I'll always give you the solubility rules if you need them, but you need to be sure how to use this table to determine whether a compound is soluble or insoluble. All right, and I wanted to just finish off, because we typically use KSBs for compounds that we would generally classify as being slightly soluble, or we might have said are insoluble. We can see that the KSP values tend to be really small numbers. And so this is just representative. They can be as small as 10 to the minus 40 or 10 to the minus 50 for things that have really low solubilities. All right, so I'll follow this up video with several videos of examples that we can do with these solubility products.